Now I've run way over here, but I ain't done if y'all want to cover some more on this. First of all, on what we've talked about so far, any questions?
I do have one. Does it matter whether you're using stranded wire, solid wire,
No.
or using it insulated?
It does matter if you're using insulated, not from an efficiency standpoint, but from a tuning standpoint. So the insulation uh, changes the electrical length of the wire some because of the not the permittivity, the no, well the no. I'm sorry, I'm having a Joe Biden moment. Pardon me, but the older more of those I have, it's
the Lovell effect.
No, well anyway. Okay, so Glendon, yes.
Have you had any experience using the Palomar ununs or ballons?
No, yes, I think, I may have it at some point, Glendon, but I don't remember specifically what I was doing or where it was. They may be fine.
Okay, because I'm trying to build a.
I've tried a number of different ones, but I keep coming back to the Ballon designs.
Okay, because I was trying to build what is it? It's a loop antenna, a folded dipole loop antenna. I can't remember what it is. A turbinated folded dipole. It just came to me. And I was using I haven't built it yet, but I've got their Ballon or unun and resistor. And I just wanted to know if you'd had any experience with that.
I do not. I would ask you, the first question is, why do you want to try this one? That's not questioning whether you're making a good decision. What I'm questioning is, why did you make that decision?
Well, I was trying to get something that would fit on my property and basically just have it draped down the roof on both sides.
Okay. All right. So it was essentially fitting it into your real estate is the reason why you're wanting to do this. Now, I would ask the next question is because this may be a trade-off that you have to make and want to make is, does this shorten the length of the radiating element?
Well, after seeing what you put up over at Anthony's house, that may be more functional or feasible for me to do because I can do that real easy.
Well,
just run the wire around, basically run the wire around the roof and then around the fence.
There is that possibility. I'm going to mention one to you that's really out of whack here. But I had this as a receive antenna when I was a kid. Around the edge of your roof is typically an aluminum strap of some form. Drive a nail into that, hook the center conductor to the nail, and go to earth ground with the other side of it. Plug your coax into that, and you need a tuner. Hopefully the tuner is at the feed point of the antenna, but even if it's not, you might be able to get on the air with it.
Okay.
Yes, sir.
I know you talked about the alternative dipole, but for a center fed converted V, what would you recommend for a Ballon on that? 9-1 for that or 1?
No. That's 1-to-1, always 1-to-1.
But can you repeat the question for the?
Yeah. Okay. So the question was on a center fed dipole. What do you need to use for a Ballon on the feed point? You don't necessarily need a Ballon at all, but if you don't have a Ballon, you're going to need a common mode choke. And that common mode choke may be nothing more than a piece of RG58 wound in a loop about this wide, 7 loops, tape it together and hook it right up at the antenna. That may do the trick adequately for you. A center-fed dipole has a balanced feed point of approximately 78 ohms. Now, if I hang it down as an inverted V at an angle of 120 degrees, that feed point becomes approximately 52 ohms. Bingo. Not only that, but the antenna becomes practically omnidirectional. So it's a real good choice. And if it's a 40 meter, it's 40 meters and 15 meters both, assuming you've got it tuned lengthwise to 7 megahertz. All right.
Hey, Bud, Mike,
Yes.
I got the same problem. Looks like Rebecca has. I've got a metal fence along part of my backyard. How far away do I have to be from that fence if I wanted to run a chunk of wire?
I saw a center fed dipole strung up through the top of a chain link fence, and the dadgum thing worked. So what I might suggest is try it and see what you get.
Add on to that, for attic antennas, my whole house has this aluminized coating, so the roof and everywhere. So it's a Faraday cage. So attic antennas don't work in that case. So if you're doing an attic, make sure you take a look and see if your interior is coated with aluminum stuff.
Yeah, if there's a radiant barrier in your attic, do not put antennas in your attic. If you have a steel roof, do not put antennas in your attic. Now, in both of those cases, if your antenna is close to the roof, I say close within about 30 feet, you're going to need to make sure that you pay attention to the type of balun that you use. The notes on Balun Design's website will tell you, if you've got this, use that one. If you don't have this, use that one. So there are some technical reasons. Particularly with current baluns, you could find yourself in a situation where your steel roof on some of the bands is causing one of the ferrite cores in the balun to overheat and damage the core.
You're saying that specifically if your antenna is outside your metal coated or metal? Yes,
just near a lot of metal. Yeah, my brother, I gave him one with a I'm pretty sure it was either a 4114 or a 4115 Balun Designs OCF Balun. He's got his ham shack in a shipping container, and he's got a tower right next to the shipping container. We got the dipole, off center fed dipole, hanging from the tower. He's had no trouble with it, and boy, that sucker worked. He does not need a tune. He was tuning everything all the time. He had fan dipoles and he had to use a tuner. He's lost the tuner. He doesn't need it anymore. It's gone. But again, this is not a stealth antenna. It's up on a tower about 35 feet off the ground.
That's the key, elevation.
Yeah, that helps immensely. Now, I had something else I was going to show you guys, but I need to be able to share again. Can somebody set me up where I can share again?
Have you tried sharing again?
Well, maybe if I push the button that says share.
Try again.
Okay, it says you are sharing. All right.
I think you're maybe not plugged in. Yeah. He lost power on his power was getting low, I think is.
I'm on there. I don't know what happened here. Plug it back in. Well, go ahead. Okay, so this is a tool. This works on Excel. Okay, I do not support any of the things that I do on any other. If you insist that you're going to use OpenOffice or you're going to use Google Sheets, more power to you. I can tell you with Google Sheets, the colors don't work. I will not fix it. If you want to fix it, fine. Have your own self. This first sheet we're looking at, I downloaded off of Balun Design site. I did not develop this. I did make a couple of minor changes in it. Now, I will not post this online, but I will give this to anybody who wants it. Plus, I've added some extra sheets to it. Let's see, I need to. All right. So what you do with this thing is you start out up here at the top. Everything on any spreadsheet that I do, if it's blue, it's a data entry. If it's yellow, it's a calculated value. Don't change it. All right. Look up there at the top. There's a frequency in megahertz that you place into this. In this case, I've got 3.560 megahertz as the starting point. So I want to build basically an 80 meter off center fed dipole. I can use this for any dipole, center fed or in fed, either way. The next one underneath it is use number 14 or number 12 solid or stranded wire. This guy's smart. He was right on that. Enter a 1 for bare wire or 2 for insulated wire because the insulation will change the tuning slightly. Then
why would you need insulated wire?
You don't need insulated wire. You can choose and use either one, but insulated wire is easier to hide. Black wire is harder to see than shiny copper wire if you're trying to hide it.
So when you made the comment earlier about the EHHN, the insulation going off, the only real reason that you were concerned about that is for the aesthetics.
Precisely. Well, now, when the insulation gets off of it completely, it will change the tuning of the wire a little bit. But you can always go back. If you follow my advice, you can always go back and tweak it, right? So no, it is not necessary to have insulated wire. I'm suggesting it because it's easier to hide. That's the only reason. Okay, next one down, enter the OCFD feed point offset. One that works for the most bands seems to be 28.9%. The standard off-center fed dipole offset is 1/3, 33.3%. But the guy that actually did this did some modeling and said, what offset will give me the most bands at 200 ohms impedance? So I'll have the lowest SWR. Remember, SWR is dependent on impedance, not resonance.
Does that change if you're starting with 75 meter versus 80 meter? Or
you for an off-center fed dipole, it has to be tuned for the bottom end of 80 meters. So you're not going to be able to use 99% of the time. You are not going to be able to use 75 meters without a tuner on an off-center fed dipole. Okay. All right. So then notice underneath this, it gives you a picture and gives you a wire length. I even have a table over on the far upper right over there that's feet and inches. So if it's 0.2 feet, that's 2 inches. If it's 0.3 feet, that's 4 inches. If it's 0.6 feet, it's 7 inches. So I just, it's just a little quickie glance over at it. You don't have to be particularly accurate here. Oh, I don't know why this is doing this because I've got that turned off.
Plug it back in.
Oh, well.
There we go.
All right. Okay, so you do that. Hang your antenna, and then get out your antenna analyzer and measure the frequency on the 80 meter band that gives you the lowest SWR. I said SWR, not resonance. How do you tell when it's resonance? Look at resonant looking at your antenna analyzer. X equals 0. Okay, so tune for the lowest SWR because that's where you've got the closest impedance match. Then you come in right over here and enter that frequency. I've got 3.360 megahertz in here. This is just an example. I'll just pull these out of the air. So then it's going to come down and it's going to tell you to shorten the short side by 2.2 feet and shorten the long end by 5.52 feet. So lower your antenna, make the adjustment, fold the end over on itself, tape it up, get it back up into the air. Now, go back and check it. You should have a real good SWR on 80 meters at the bottom end of 80 meters. All right. Now, remember that graph that I showed you where as you went up, they shifted either one way or the other from the band, the lowest SWR. I got to make this thing useful. So you come down here to Final Adjustment tab, click on that Final Adjustment, and then coming off on this side over here, in any band that you're not going to use, leave the blue spot empty, and then measure the frequency at which you get the lowest SWR for each of the rest of these bands. And what it's going to do is it's going to calculate what we call the K factor, which for all intents and purposes is the velocity factor. And then this spreadsheet will average that velocity factor and recalculate the length of your antenna, which you'll see over here. It will tell you to add 0.99 feet on the short end and add 2.44 feet on the long end. And then it'll give you the best average over all of those bands that you were wanting to operate. Now you're done. You don't have to lower the antenna and crank it back up again. You're done. Unless, of course, you want to say, you know, I'm willing to give up 15 meters in order to get better on 10. So then you just come over here and zero out the 15 meters and let it calculate 10. Yes, sir.
When you're shortening, if you're using insulated versus not, does it make any difference if you're folding it to shorten it?
No, that's what you want to do is fold it. And that is exactly what you want to do is fold it.
You don't want to cut it, because then once you cut it, you lost it.
It's over. Now,
how do you say you make it ignore 15?
Yeah, just come over here to 15 and put a 0 in there.
It takes it out of the averaging.
Takes it out of the averaging. Notice that the short and long are different now.
Yeah.
Okay. So then you're going to go in there and make another adjustment to get the length that you want.
How do we sign up to get this from you?
No, all you have to do is give me your email address. Okay. And yes, I'm willing to do it, and I'm also willing to help you over the phone if you gee, I'm confused, did I screw up? Now there's one more thing I want you to pay attention to, and I have forgotten what happens here, but I found, I don't know, 8 or 9 years ago, I found a paper on the internet that a guy did where he was testing feed line lengths that were within about 5% of an odd multiple of quarter wave. Theoretically, whatever I connect on this end of my coax is going to show up on this end of my coax, unless it's an odd multiple of a quarter wave. That can be a problem. I don't remember what the problem was. It skips my mind. But what I can tell you is, I went back and I checked his math. I did a little more evaluation mathematically, and I said, by God, he's right. So I created this worksheet. And basically what this thing is designed for is to give you a little tool that will keep you from getting on a multiband antenna, getting a feed line that is within 5 or 10% of an odd multiple of a quarter wave for that band. Notice over here on the left, I've got green and red lights. This will not work on Google Sheets, okay? I'm just telling you. There's another thing over here you can do, but basically what we do is you go up here to the top and you select, notice it says input, blue is input, brown is derived, so is yellow. Over here is it shows the speed of light. Notice I've got it fairly precise. This blue over here under units, you can either select IP or SI units. If you select SI units, everything will be in meters. If you select real units, then everything will be in feet. Anyway, what's the tolerance that I'm looking for here? I've got it in at 5%. There's over here on the edge, there's a little table. You can put in your coax that you want to use, and all you really need is the general velocity factor. It's usually posted with the manufacturer. Now that velocity factor actually varies a little depending on the frequency you're at on the coax, but this seems to work well enough. So I come in and click on this spot right here. Oh, sorry, wrong side. Click on that spot. Notice there's pull down. Click on the pull down and select the coax that you want to use. And it'll go ahead and get it off that table and get the velocity factor out of it. Then how long is my cable? In this case, I've got RG8X, 75 feet long. So how do I know it's 75 feet? Well, it's on the label. Seriously. I didn't measure it. It's close enough. It's on the label. Then what it's done is it's told me that 20 meters is going to be a problem, 12 meters is going to be a problem, and 6 meters is going to be a problem. Now, if this worksheet works on Google Sheets, and it probably does except for the colors, you can come over here to the far right side, and anyone where the word safe is listed, it's green on the left. Anyone where quarter wave multiple, is it even? If it's even, it's safe on the left. It's green on the left. If it's odd, it's red on the left. It's that simple. Yes, sir.
Sorry about the little question. Your feed line, is that from everything starting at your radio?
From the
tuner to your bulkhead to a lightning arrestor, or is it just the
it's from the tuner. I would say from the tuner, yes. And that's kind of nebulous, okay? But I would say from the tuner, from the last device that has discrete devices in it, like the tuner. Now, what frequency do I want to work at? Notice over here on the far left, I've got a blue with a 14.25 in it. That's a 20 meter band. I want to be able to operate best from the voice side of 20 meters. What frequency do I want to use as a fundamental for my OCF? And notice up here on 80, it's got tune frequency in megahertz 3.56. That's where I got that. If I change this to 14.1, then it's going to say 3.53 megahertz for the fundamental frequency on the 80 meter. Okay, so it's just another little tool at your disposal to make things a little easier. This first sheet, the dipole calcs, that's not my worksheet. I did not change any of the basic calculations in that. I'm not sure what it is he's doing. I didn't take the time to go in and delve in and make sure I agreed with how he did it, because it works. But I made a couple of modifications to make it a little easier to make an initial adjustment, and then I added these two other sheets. I'll probably add some more later, worksheets to this, but anybody wants it, just bring me your email address and I'll send it over to you. Any other questions on this?
My question is on specifics on the OCF.
Okay.
So the question is, if we have an efficient 49-to-1 infed half wave on ongoing, compare that to an efficient OCF 4-to-1 Fallon, is there a reason to prefer a 4-to-1 over a 49-to-1?
What the 4-to-1 you're going to use on an OCF. The 49-to-1 you're going to use on an infed.
Do you care about does 49 or the 4 make any difference to you as long as both efficient?
No. No. Now
I mean they have to have their purpose. I understand you're tuning a 2450 ohm piece of wire on the infed half wave.
No, the infed half wave, it's not a 50 ohm. It's nearly infinite. That's the reason.
The wire alone, yes.
That's it. Yeah. So then you're going to put an onion on it, 49-to-1 to get you to 50 ohms. Guess what? You ain't at 50 ohms, because infinity divided by 49 isn't 50.
Okay.
Okay, it's just you're closer.
Okay.
All right.
You're still falling. Yeah.
Basically, yeah, that's a fact.
Okay. So you're working with something that's more a more steady calculation if you're doing an OCF.
The OCF feed point can vary anywhere between 200 and 300 ohms. Remember, with a center fed dipole, if it's horizontal, that feed point is 78 ohms, not 50. You get it down to 50 ohms, you got to droop it into an inverted V.
Okay.
The same's true here. If you're dual straight across, it's really 300 ohms at the feed point, not 200.
So
droop at 120 degrees and it'll come to 200 ohms.
Well, it's naturally doing that. So could it be used on the OCF? Is it preferred for the balance, the center point, the peak point to be at the peak of the V?
If you want 200 ohms, yes. The best propagation shape is going to be if it's bent 120 degrees at the center point. But I believe it needs to be at the feed point to make sure you get 200 ohms.
Okay, feed point versus center point.
But guess what? The difference between 200 ohms and 300 ohms divided by 4 is close enough that it's well, twice the number of ohms is a 2-to-1 SWR.
Okay.
So if I've got a 50 ohm interface, but the feed point it's actually 100 ohms, I've got an SWR of 2-to-1, which is it ain't broke, don't fix it. So basically what I'm saying is as long as the SWR stays low, don't worry about it. Plug it in, see how it works. Anything else?
A couple comments on Zoom.
Okay.
Rebecca was asking Anthony about his antenna. Are those single-side DX contacts?
Yes.
Single and FT8 and FT4?
And you said single-side band?
Yes.
Okay. And Rebecca, I guess, made a comment about Miele just came out with a 25-foot whip. So the benefit of that is that you don't need a coil for 30 meters, 25 feet. So that just came out.
This is Bud's second law of antennas. The longer the radiating element is up to a quarter wave, the more efficient the antenna is going to be.
And Mike had a couple comments. Mike, you want to explain your post in chat? Any questions or comments on that?
Well, I searched for the antenna, and the first link was, I guess, an older version. It looks like it's the exact same numbers. It just the second link is, I guess, the current version that includes how to rig it up if you want 80 or 40 and using a coil, I guess. So basically, they're the build plans and the SWR outputs and how long the radios have to be.
Are you talking about the POTA Performer?
Yeah.
Okay.
Yep.
He updated the POTA Performer within the last month or two, and I have the specs. I sent them to Sam and Rebecca too. I'm happy to send them to the whole group.
Do those specs include the links for the segments for the radials?
They did on the second version, which is the version Sam and I have. I do not know about the third version.
Because the version that Sam sent me only has them through 20 meters.
Okay.
So yeah, it would be nice. Otherwise, we'll have to do some calculating to figure out.
I know he said on the second version for 40, you just take the entire 20 meter one, and instead of having two verticals, or excuse me, two radials, you just use one, and it does work. I've used that.
Yeah,
okay.
I did some calculations based on kind of what he had extrapolated, and so I've got the dimensions for the elevator radials for 30 and 40 meters. So I can share that.
Okay.
And I think, Mike, if I saw what you had there, Guy created the POTA Performer antenna. It has another antenna called the Predator. I believe that's up to 15 meters. So that, just don't want to confuse it. It's another
It's a half wave instead of a quarter wave.
Yeah, and it is a vertical.
Yes.
Yeah, I saw that.
I'll send that around to the. Mike, do you want me to just drop that in groups IO?
Yeah, that works. You can stick it in the I think there's a presentation folder.
Okay, sounds good.
Mike's got his hand up again.
Yeah.
Can you hear me?
Yes, Glendon, go ahead.
Unfortunately for me, I'm at work and I have to start doing my job. Anyway, I wanted to thank Bud for the presentation. All the information's been very informative, and I'm glad that he would take his time out for today to help us all with this, because I mean, that seems to be the biggest thing most hams are dealing with is antennas. So thank you again, Bud, and y'all have a good day.
Well, Glendon, thanks for the positive feedback, and I want to leave that with everyone else. Was this worth your time?
Absolutely.
Oh, well, yes.
Just remember, Bud doesn't know anything about antennas. He thinks he does.
And I do have a couple of comments to say. 90% of your station is your antenna. The other thing is, I tell people on the radio, because they can't believe how I'm operating so close to the ground, I tell them it's like when propagation is working, it's working. When it's not, it's not. I know what my limitations are, and I may not win any contests, but at least I'm having fun doing it.
Well,
and my backyard is a lab in a sense because we don't know how it's radiating.
And that antenna does not work. Would you please stop making contacts all over the world?
I will.
No, seriously, it's terribly, and I'll show you because I've got the Rig Expert scans. It's terribly reactive. So basically, in a nutshell, that antenna sucks. So stop making all these contacts. But it goes back to that earlier point. It doesn't have to be perfect, because the difference between S9 and S8 is you can't hear it. It's just not there. That's like 6 dB. That's 4 times change in power, right? So the fact that we've got inefficiencies in the antenna, and you probably noted that I was kind of emphasizing, let's make it efficient. Let's try. You want to try and make it efficient, but then you got to deal with what you got to deal with. The world is what the world is. I live in it, and I got to deal with it. So we work with what we have.
And I will say this: since I'm visually impaired and blind, I'm using amateur radio and seeing through the airwaves of who I can make in contact with. It's amazing what I'm seeing.
Well, see everybody at HF.
Okay, so I need to get out of this.